So this presentation is about, as was
Sure thing.
about a recent paper about a concept that we call substantiation. We will talk about it in a bit later in this presentation. So, the outline. I will first discuss why replication. Why is it important to talk about replication? Then classifications of replication research, limitations of these classifications, and then I will introduce our concept of substantiation research and give some illustrations about it. Okay, so why replication? So, at the very beginning, somebody might ask, why should we worry about, because replication means doing another study again. That's basically the definition of, repeating a study again. So somebody might say, why should we repeat past studies and publish them in top journals instead of finding new things? Isn't science about finding new things? So why should we do replication research, let alone encourage it also? So the answer is that if we don't do replication research, we will create an incentive structure that favors innovation over verification. So we run the risk of unreplicable findings accumulating. And as we have seen in different fields, this has led to replication crises, confidence crises, and ultimately this will devalue science itself, because people will not know what to trust and what not to trust. But when you actually do replication, there is what I call the replication dilemma. Because if you find the same results as the previous study, the reviewers will say, yeah, we already know that. The paper that was published 1 or 2 years ago found the same thing, so you are not bringing something new. And if you don't find the same results, they may blame you. They may say, oh, you are not an expert, especially if you are replicating a paper by a big name, or they may say, oh, there was some deviation between your study design and the design of the study that you are replicating. So, in the end, you will have to justify why these results are different. So this is the replication dilemma. We will come back to these issues. These are very fundamental issues in replication research. So what are the different types of replication research? Not all replications are the same. There are different types of them. But as it turned out, there is actually a confused terminology in the history of replication research. In this paper, for example, by Clemens, there are so many different types and names proposed in the literature, like, for example, strict replication, type 0 replication, type 1 replication, type 2 and type 3 replication, scientific replication, statistical replication, experimental replication, and all these different types that different fields have come up with these different terms. There is some overlap between them. Sometimes there is no overlap in some terms. So it's very confusing. When it comes to language learning more specifically, this is an influential paper published recently in the journal Language Learning. The authors proposed 3 types of replication. There is direct replication, partial replication, and conceptual replication. And these are very standard in the field of applied linguistics and second language acquisition. For direct replication, there is no intention to make any change to the study you are replication. Partial replications, you introduce one change to a key variable, for example, the age of the participants, or the context, or the duration if it's related to time, or the instrument, or how you ask your participants. You make only one change, and this is called the partial replication. And then conceptual replication when there are more than one changes. Also, in another influential classification, Graham Port and Kevin McManus, this is what they say: we do not want to add to the confusion here with more definitions. So they propose more definitions. They have close replications, approximate replications, and conceptual replications. In close replications, there is change in one variable. Approximate replication, change in two variables. And conceptual replication, there is more deviation from the study you are replicating. Notice that there is no more direct replications according to this classification. They start with partial replication and they call it close replication, where there is only one change, because they say you cannot have a direct replication, there is always one change. And then they have two changes and then more changes. Okay, so what does this all mean? This means that there is a lot of confusion in different fields about different people proposing different terminologies, and even different fields have different terminologies. And in language learning, there have been some proposals. So replication terms are not really set in stone. So if somebody from complexity theory perspective, for example, they want to propose some terms, it's not like something fixed in stone for centuries or something. It's something that happens all the time. So why should we propose different things? There must be some limitations to the existing classifications in order to justify proposing a different terminology. So let's look at the limitations of the current classifications of replication. First thing, how do we interpret failed replication? As I said at the beginning of this presentation, when your results do not support the study you are replicating, reviewers may say, oh, you changed something, there is maybe you didn't adhere to the design, or maybe you lack the expertise, or whatever justifications might come up later. So if failed replications do not question the initial results, what's the point? If they do not unambiguously question the initial results, then there is a problem. And this doesn't always happen. There is always leeway when the results are negative and they do not support the initial results. How does this apply to open systems? In contrast to to lab controlled settings, many phenomena in nature are very complex. How can you know that your results, your design is direct and or approximate or partial? You change only one single variable in a complex system. It's very difficult. We will see some examples later, some tangible examples later. It's very difficult. Does this really apply to complex systems at all? Even if they follow a deterministic structure. This paper by Lawrence in the 60s, this is the paper that first introduced what came to be known as the butterfly effect. And what most people remember about this butterfly effect is, a butterfly flapping its wings in one area and then causing a hurricane or whatever in another region. But I'm not interested in that analogy now. I'm interested in that structure being deterministic. And even if it is deterministic, you cannot predict what will happen in the future because it is very sensitive to initial conditions. One change in the 10th decimal point will lead to drastic differences in prediction. So if you fail to replicate in this case due to sensitivity of initial conditions, does it make sense to say I want to replicate this study when we know because of measurement problems that we will not get the same results before we do the study? These are open questions. So when the replication fails, does it question the initial results or our own lack of knowledge about what we are studying, because it's something very complex? These are still open questions. Should we call these replications anyway if we do a partial replication, or should we call it an extension, as we will see later? If you do a conceptual replication and you change more than 2 or 3 variables, is it really a replication or is it a completely different study now? Why should we call it replication in the first place? We will see later some other recommendations to address these terminological problems. So let's continue with the limitations. Conceptual replications are in a weaker position for ascribing different findings to the adaptations made to initial study. Inherently, it's an inherently weaker position when you do conceptual replication, which is a major limitation. If you do a conceptual replication, you are at a disadvantage, which is a problem, of course. So conceptual replications can be a more high-risk undertaking than close or approximate replications, in the sense that failure, again, we are about failure now. If the results are positive and you replicate, okay, everybody is happy. But the problem is when things do not work out the way we want and you fail to replicate the initial study, what are we going to understand from the results? Failure to replicate will leave us with little or anything to say about the original. So we have a problem with negative results, and we always expect failed replications, but we cannot interpret them. This is a problem. If our study did not come to the same conclusion, can we say we have conceptually not replicated the original? Obviously not. So why do you call it a replication if you are not going to call it we could not replicate? It's confusing. There's a lot of confusion here. When a conceptual replication fails to support a theory rather than reduce our belief in the theory, we are tempted, again, to explain the failure in terms of methodological problems with the operationalization of the key variables. As such, conceptual replication has been described by critics as solely a mechanism for confirmation bias. And this is important. Confirmation, and it's a very subtle point. What confirmation bias here means is that if you do a conceptual replication and your results are positive and they support the initial study, you will be happy and you will publish your results. But if they are negative and they do not support the initial study, you will not publish your results. And then this is the bias. Only positive results are published. So there is a confirmation bias here. So this needs to be addressed. The likelihood of being able to publish a conceptual replication failure, again, the same point, in a journal is very low, which is true. But here, the failure will likely generate no gossip, even in informal channels. There is nothing interesting enough to talk about here. So even in informal channels, people are unlikely to talk about failed conceptual replications, let alone publishing them in a journal, let alone in top prestigious journals. So we have some limitations here about the existing understanding of what a replication should be. How do we judge the success of a replication? That's another important, we have been talking about, successful replications, unsuccessful replications, positive and negative results, but how do we judge? So most social science theories offer only qualitative trends. They say, if you do this, you will get better learning or faster learning. But how fast? How better? When can we say that the results are not true if you are just saying better? You're not giving exact numbers. Do you say, for example, the effect size, the theoretically driven, this is point estimate of my effect size is 0.41, for example. On what basis can you say this in the social sciences? Okay, in physics, you will have, you estimate things and you will have equations and you will say the value I expect from based on my theory is this value. Can you do this in the social sciences? You can't do this. So how do you judge then that the replication is successful or failure? You can always reinterpret the results. You don't have replication intervals. Outside these intervals, you say that, okay, now we know that the theory is, questionable now. Do single study replications make sense? So, and let me explain this more. So in this study, which was published in 2014 by David Stanley and Jeffrey Spence, expectations for replications, are you realistic? Here, this is the key point here. In the first set of simulations, study results differed substantially across replications as a result of measurement error alone. This raises questions about how researchers should interpret failed replication attempts, given the large impact that even modest amounts of measurement error can have on observed associations, just like the Lorentz study about the butterfly effect that we talked about, a few slides ago. So let's see what these researchers did. So let's imagine that this is a simulation, so it's mathematically correct. There is no question about it. If your effect size is 0.1, your results could be all the way between like 0.35 to -2. And all these are possibilities. So what does this mean? If you get 0.3, or if you get something like almost -0.2, you do not falsify the original study. So how can we interpret your results if with this broad range? It doesn't make sense. And then they did some other simulations. They did other simulations, even with the reliability of 0.9, a larger sample size, you can see there is a relatively wide range of or a large interval, a replication interval, let's say. So if you get a 0.3 and somebody replicates you, are they going to get 0.3? And if they get close to 0.1, is this considered a failed replication? Let's see what these authors are saying. This is a very important quote. If Jane had observed a correlation of 0.46, that's a very high correlation, relatively speaking, in the social sciences, in her first study attempt. Okay, a colleague from the same university, Richard, might attempt to replicate Jane's findings under an ideal replication scenario using the same participants. On the basis of the above results, Richard could conceivably observe a correlation of 0.03. You can see the difference here, even though using the same participants. The low correlation obtained by Richard might lead him to wonder if Jane engaged in unethical research practices or made a mistake, especially given that he and Jane used the same participants. Usually we don't use the same participants, so we should expect even a larger discrepancy between results, yet obtained a substantially different result. However, in reality, the only reason Richard's findings differed from Jane's was the random measurement error associated with the criterion. So this is an important consideration. How can we interpret failed replications considering this wide replication interval that we should expect? So what these researchers are suggesting is shifting to a meta-analytic mindset emphasizes that a single study provides information, but that this information is limited. A study may be best viewed as a data point in a broader data set to be examined via meta-analysis. This is a familiar mindset and is analogous, this is the important point, to how a researcher may view the contribution of an individual participant in his or her study. A researcher would never interpret an individual participant data through a lens of verification, whereby participant two's data is viewed as replicating or failing to replicate the results for participant one. Likewise, the data from one study should not be interpreted as replicating or failing to replicate the result of another study. Now we have a problem if we follow this, because does it make sense anymore to talk about a study replicating another study? Or do we need to have like 10 studies, then do a meta-analysis? So does this mean that it doesn't make sense to say one replication study? These are important considerations. So how do we interpret individual results? Especially now when we go and do meta-analysis, we have to consider the significant filter and publication bias. This should be significance filter. I'm not even going to talk about social aspects of doing actual replications, like bullying and journals not being favorable to it, and etc., etc. So this is a whole different story that I will not talk about. I'm just focusing on the science and the theory of replication here. So some people even suggested that we divide novel effect sizes by a number between 2 and 10, which is very big. So if somebody publishes a paper and say, wow, look, we have this new effect and it has an effect size of 0.4. So these people say, well, you should, maybe divide this effect size by 2 or 3 or even 4 and say maybe your real effect size is 0.1, not 0.4, which is hardly anything then. And this has to do with p-hacking and phishing. This is an important paper. The Garden of Forking Paths, why multiple comparisons can be a problem even when there is no phishing expedition or p-hacking. And the research hypothesis was posited ahead of time. So when people talk about phishing expeditions and p-hacking, the image they have in their minds is that somebody doing 10 analyses or 20 analyses and comparing the results and then picking the best result that support their theory and publishing that study. But in this paper, the authors argue that this doesn't have to be the case. Even there are subtle cases of phishing expeditions that do not feel like phishing expeditions. So, and they give examples in this paper, and they say that the analyses presented here do not feel like phishing because it would all seem so reasonable, but they are still, phishing expeditions. Whether data cleaning, this is important, and data choices were made, whatever, contingent on the data, would seem to researchers as the single choice derived from their substantive research hypotheses. So we have a problem with data cleaning, and many people forget this. And analysis choices, even before you do your inferential statistics, so you may do one single t-test or ANOVA or regression, and you say, I have not done anything else, and this is the test that I wanted to do from the very beginning. Still, there might be some p-hacking because of the data cleaning procedures that you did. How you combined groups, how you sorted out whatever, the outliers, the what you include, what you exclude before you do the analysis. All these data cleaning procedures can contribute to p hacking. So there are a lot of problems that I have discussed so far. So let me now talk about our suggestion to address some of these problems. So what we call it here is the substantiation framework. So let me talk a little bit about it. So we argue that there need to be 3 conditions before you can do a replication study: result interpretability, theoretical maturity, and terminological precision. And I will talk about each one of these in turn in the next slides. So, results interpretability. Now, as I have been saying from the very beginning, whenever I talk about replication and the different types of replications, we compare the design of the initial study and the design of the replication study. If they are similar, we call it direct. If it's different, we call it, partial, conceptual, close, approximate, or whatever. So the basis of the classification of replication research is based on the operational characteristics of the 2 studies. And this is the problem. This is the biggest mistake that have been done in the science of replication to date. Instead, and this is a new paper published in 2020, a replication has to be any study. So a study for which any outcome would be considered diagnostic evidence about a claim from prior research. What does this mean? This means that only if positive results support the initial study and negative results question the initial study, then we are justified to say that this is a replication study. In many cases, as I have been saying from the beginning of this presentation, in many cases, when you get negative results, you cannot question the initial study. There are a million other interpretations. This means you cannot call your study a replication because there is evidence only when you have positive results. If you have negative results, you cannot. There are a million interpretations. This is not a replication study. You have to have a design where both positive and negative results are interpretable. How can you do this? We will see in a bit how to do this. So the first thing is result interpretability. How to do this? Theoretical maturity. If you don't know what you are studying, of course, there are a million interpretations. But if you know what you are studying, you have theoretical maturity, then you explain the necessary and sufficient conditions to obtain a finding. And this is not really that new. It's just that this idea has not been incorporated into the science of replication research explicitly by many people. So even if there are some design deviations, we can still call it a replication, even if it looks like a conceptual replication on the surface or a partial replication, but we are satisfying the necessary and sufficient conditions, then it is a direct replication. It's just a replication. We'll see different types later. So we do not start looking at the design at first glance. We look at the theoretical assumptions. And this is, one proposal here is called the constraints on generality statements. We will see in the next slide an example. Here is the problem. The current publishing model incentivizes authors to make the strongest possible claims of generality. So, for example, you have a study with 100 or 200 participants, you get an effect size of, say, 0.2, 0.3, 0.4, and you say, this applies everywhere, everything, just nothing, everything, the broadest possible claim. And this is how it gets published. This is the publishing model. Broadly generalizable findings are more likely to get published. And if people comment on the limitations of their research, they say, oh, my participants are college students only, and then they stop here. They do not talk about the theory. Should the theory be relevant only to college students? Why or why not? What do we expect? It's usually silent. They don't say, just, oh, limitation is that it's questionnaire based, full stop. Another limitation is that its age is between 18 and 24. Full stop. Further research should look at other age groups. What do you expect? What does your theory say? Should it apply or shouldn't it apply? It's silent. This is a problem. So failed conceptual replications, if there is sufficient theoretical maturity, will still have evidential value because you are checking you are verifying the processes posited by the theory. You are actually testing the theory. You are not really repeating the same design again. So, as I said, constraints or generality. Let's talk a little bit about what a constraint or generality means. So this paper published in 2017, Constraints on Generality, a proposed addition to all empirical papers. So what these researchers are suggesting is that we propose that the discussion section of all primary research articles specify constraints or generality, a COG statement that identify and justify target populations for reported findings. They talk not only about target populations, but other things related to the study design. In this paper, they have several examples. Let's look at one of their examples. So in this example, it's called highly repeated within person paradigm. They examined the relationship between support seekers' expression of distress and participants' willingness to support them. So they had two conditions. If there is distress and the participants were willing to support it or not, they did a study, and their results showed that their willingness to help reliably decreased. So they had a negative relationship between two conditions. Now, how do they write this is an example of a constraint on generality statement. Let's read this and see how they did it. The stimuli consisted of a large number of video clips in which a large number of different undergraduates sampled from the subject pool at the University of Washington, each expressed mild distress in their own way. Thus, we expect the results to generalize to situations in which participants view similar video clips, as long as manipulation checks indicate the clips depict a variety of ways in which people express mild distress. So now they are saying that this applies to any type of video stimuli you use in your replication study, as long as this point is satisfied. They express mild distress. Unpublished studies from our laboratory resulted in similar results despite variations in the testing condition, different research assistants. Consequently, we do not expect such variations to matter. We believe the results will be reproducible with students from similar subject pools serving as participants. However, we do not have evidence that the findings will occur outside of laboratory settings. So this is, now they state the limitations of this. The distress expressed in the video clips was triggered by specific laboratory induction, and we lack evidence showing that the results will generalize to expressions of distress in response to other situations. Notice they are not claiming the broadest possible interpretation of their results as usual. They are saying we are limited to this situation now. So if you do a study and you use different outside the laboratory, for example, or different types of expressions of distress, then you are not really replicating the study. They are saying we do not have any claims about that area. This is the limitations, the theoretical limitations of our study. We have no reason to believe that the results depend on other characteristics of participants, the participants' materials or context. Okay, so this is an example of um, constraints on generality. The third point is terminological precision. So as I said, earlier, are these types really replication? Some of them look like extensions. If you just like in this study here, they said, we lack evidence showing that the results will generalize to expressions of distress in response to other situations. If you test these other situations, you are not really replicating the study. You are extending this study, right? Should we call it a replication then? Or it doesn't make sense to call it a replication. This is the problem with terminological precision. It's not a replication. What are you repeating here? They say we don't have evidence. Or is it a generalizability test? Or is it a follow-up study, for example? And therefore, some researchers argued that saying a conceptual replication is a practical oxymoron. What are you repeating? There is nothing that you are repeating. Why are you calling it, a replication when you are not really repeating something that somebody else has done? It doesn't make sense. So the problem is that the word replication is center stage. Everybody is talking about replication. It's the umbrella and everything falls under it. This is the problem. But many things are not literally replications. They should be called something else. And this is what we suggested. So this is a table from our paper. From a narrow focus on replication to a broader focus on substantiation. This is the term that we suggested. So as you can see here, we first distinguish between theoretical maturity and immaturity. We look at the function and the methodology. Replication will be direct, and extension will be conceptual. Here, we do not have conceptual replication. This doesn't make sense. You cannot have a conceptual, as I said previously, a practical oxymoron. You cannot have replication, but then conceptual. It has to be direct because there is theoretical maturity, and you are testing the theory directly. It's just direct. If you extend the theory, then it becomes conceptual. You cannot have, a direct extension or what doesn't make sense. There is direct replication and there is conceptual extension. In this case, if you have positive results supporting the previous study that you are replicating, then you increase confidence in the theory. If not, you decrease confidence. With extensions, your positive results extend empirical support for the theory, say to the different age group or to the different context or the different stimuli or whatever. Negative results set boundaries. So you limit the generalizability or possibly reinterpret the results if you have a better theory. This is when your theory is mature and you are able to state the necessary and sufficient conditions for your theory. But if your theory is mature, does it make sense to talk about replication? And we feel it's not really a replication. You have an effect. You did a study, an exploratory study, for example. You don't have a solid theory, and then you found an effect. And when you try to do this study again to examine that effect, it's more a reproduction. It's not really a replication. You either try to reproduce it directly using similar conditions, or you explore it conceptually. So instead of extension, here we have exploration when it is conceptual. So for direct reproduction, you increase confidence in the observation. Here, increase confidence in the theory. because your theory is mature. Here you don't have a theory, really. Your theory is immature. So you increase confidence in the observation, but with negative results, we don't know. We don't have really a theory to say, so we don't know. For an exploration, positive results, again, increase confidence in the theory, possibly reinterpret it. We are trying to understand this phenomenon. Again, if the results are negative, again, we don't know. We are trying to understand the theory, and the theory is immature. Okay, so let's have some tangible examples. So far, I have been talking in general terms. I'm saying that complex system, and I'm saying different age group, different context, different stimuli, different things. Let's have some tangible examples to illustrate this point. So, example one about paying reviewers. So this is the first example. It's about academia more generally. In the second example, I will talk about education and learning. So I'm using examples from two fields. So paying reviewers. There is a movement called the 450 movement. I do peer review and I want you to pay me $450. And there is a Twitter account for it also. So these people are arguing that peer review should not be conducted for free. If you want me to review your paper, you should pay me. And some people even suggest how much you should pay me, $450. Some people say this doesn't work. They are against this idea, and there are video debates if you want to see this debate. Some people arguing in favor and not. In this recent paper, the authors call it $1 billion donation. Look at the word donation. So they estimated how much the fee for the peer review could have been if we were to pay them, and it was $1 billion in 1 year. It's a big amount of money. That's why they call it a donation. They are just, reviewers are donating their time to publishers. So there is some people agreeing and disagreeing with the idea of paying reviewers. Here, I'm not interested in thinking about whether we should or should not pay reviewers. I am interested in doing research on this idea. If you pay reviewers, is it going to be a good thing or a bad thing? I'm looking at it from a methodological perspective. How would we test this idea now? Now remember, academia is an open system. It has so many agents. There are authors, there are reviewers, there are editors, there are journals, some of them commercial, some of them not. There are universities and deans who want to promote their faculty. There are libraries subscribing to journals. There are funding agencies. There are people consuming research. There is the media. These are all different agents interacting with each other in that system. It's a very complex system. If you introduce a change to that system, it's very hard to predict what is going to happen. Now, I'm thinking about it from a methodological perspective, and then I will think about how do we even do replication, because it's an open, complex system. So each will react to other agents also. When one of these agents behaves differently, the other agents will react to that reaction also. It's a very complex system. So let's say we introduce a change. Let's say we pay reviewers, and we argue that when we pay reviewers, we will get a better review quality. We will get faster reviews. It will be fair and ethical to reviewers. You may agree or disagree with these points. Again, I'm emphasizing that we are looking at it from a methodological perspective. How can we test this? Can we do an experiment to test this? And when we do an experiment, can we replicate it? How would we do this in a complex system? So other considerations, let's see its considerations. How much would you pay the reviewers? Would it vary from one discipline to another? If you pay in biology, you pay this much. Should you pay in linguistics the same much? In neuroscience, should you pay the same much? In theoretical physics, in astronomy, and other things, should you pay? Who decides this to do an experiment? Who decides the quality to pay? To pay the review. You may get low quality reviews. Do you pay that reviewer? Who makes this decision? Where would you get the extra funds to send to pay reviewers? Are you going to introduce submission fees? In addition to publication fees, there are many journals now that charge authors to publish after acceptance. Are you going to introduce submission fees because you are going to pay reviewers? This will shift costs to libraries. How will this fit within the movement toward open science and lowering costs to consumers and to authors? What would happen to small publishers and associations? Okay, there are some big publishers that can afford it. When you say you have to pay your reviewers, there are some very rich publishers out there, but how about smaller publishers and associations working on a tighter budget? Are these going to go out of business and then it will be a monopoly of big publishers? It's very hard to predict what could happen. These are just considerations. Again, I emphasize that we are not here thinking about whether it's a good thing to pay or not pay reviewers. We are looking at it from a methodological perspective. How would we go about doing it? To study it. How are we going to deal with the conflict of interest? So, for example, one journal might have a 25% acceptance rate. Some journals have even smaller than that, but let's say around nice number, 25% acceptance rate. This means that you accept 1 in 4 papers. And for each paper, you need 2 to 3 reviewers. So you need 12 reviewers to accept 1 paper. So who's going to pay for this? And if you need to publish, tens and tens of papers a year, how many reviewers? If around 12 papers for 1 paper to be accepted, 12 reviewers for 1 paper to be accepted. How would reviewers behave now? Again, when you make a change, other agents, notice the word agents, because they will react to your change. Are some reviewers going to be tempted to review outside of their area because they will get money for it? Are they going to tell editors what they want to hear because they are hired by these editors? It's like a second job now. Will there be reviewer fraud now because some reviewers want to make money? See, it's how to predict what's going to happen. More considerations. Would reviewers agree to review for free now? Okay, as I said, big publishers may afford to pay reviewers, but smaller publishers who cannot afford to pay reviewers, what's going to happen to them? Who's going to agree to review to them now? What's going to happen? It's hard to predict. How can we test this now? What's going to happen to Diamond Open Access? How are you going to manage the millions of micro payments that you will have to pay reviewers? Especially smaller publishers. Again, big publishers may be able to create a system and pay reviewers efficiently, but what about smaller publishers? In some fields, it's very common to ask junior researchers to publish, to do the review. So you send the review to a senior researcher, and that senior researcher who is officially reviewing the paper may pass this paper to junior researchers in their lab to review it so that it's reviewer training. It's very common in some fields. So how are we going to deal with? Are we going to split the reviewer fee among these people? Who is going to ensure that they receive these fees fairly? Are big publishers going to outbid smaller publishers for the best reviewers? And the emergence of new agents. We will have reviewer academies. You see advertisements online saying, you want to be a reviewer, we will give you a course, you pay us this money, and then you will become a good reviewer, you will make money, and YouTube videos on it. Some people may have a reviewer only position. They will stop doing research. And we may have a reviewer rating system. Now it's like a job for you now. Some people will come and rate you. Then we'll have reviewer unions and reviewer mills and factories and reviewer lawsuits and all these things that could appear. So, in summary, it's very hard to do research in an ecologically valid manner. This is to make a long story short. How can you do a study? There are so many interacting agents. And if you do a study, how do you replicate it? Do you do a study in one country and then replicate it in another country? Each country has different laws, different policies, or you do it in one discipline and then you replicate it in another discipline. Different disciplines have different dynamics. How would you go about doing the study in an ecologically valid way and then try to replicate it? It's very difficult. Why? Because it's an open, complex system. It's not like you are doing a lab-controlled design that you can more or less try to replicate it. So the challenges of attempting replication in these open systems are kind of underappreciated. So let's have another example. As I said, the second example comes from education. Let's say that you have language learners and you have intervention X, and you do a study on, say, region Y, and your intervention is either, say, to improve learning or prevent, truancy and absenteeism, for example. You have an area where there is a high rate of absenteeism, and you do an intervention, and your goal is to reduce the rate of absenteeism. Then you want to do a replication. When you do a replication in another region, now there is a time difference. Let's say you do the study 2 or 3 years from now. They have different curricula. They have, different technologies available in addition to different technologies appearing, different affordances, different local laws, different faculty training in the other region, different culture, history, politics. How can you make sure that it's a replication here? It's not just a different study now, using a similar design or a similar intervention. In the sense that, as I said, in the sense that if the replication fails, you question the initial study. It's very difficult in an open system, because when the study fails, not only we question the theory, but we also question the design, we question the implementation, we question the power, the statistical power. We look at the contextual issues, like I said in the previous slide. We look at, when we do interventions in the real world, there is always a tension between fidelity to the design of the initial study and adaptation to the new context. There is always this tension. There is trade-off between generality and precision, as we also showed in that simulation research, where there is always, a wide range of replication interval. It's very hard to pin down an effect size of 0.4, and if it's not 0.4, then your theory is falsified. Inter-individual and intra-individual variation. Sometimes variation itself is informative of what works, for whom, when, how, etc. I'm not going into detail about this interaction, interactivity, interdependence, self-organization, and attractors. And, in complexity theory, if an effect replicates, it does not refer to a simple relationship, but to something that takes place in the form of complex, iterative, time-scale situation processes. So does it make sense to say I want to do a direct replication here when it is a complex system? Or your only option is conceptual, should extension is no longer a replication. So some psychologists started to recognize this. It's not just, people who are explicitly affiliated with complexity theory. So attempting to a replication in a different time or a place or with a different sample can alter the results of what are otherwise considered direct replications. The results cannot be fully understood apart from the cultural and historical contexts that define their meanings. And again, this is kind of underappreciated, especially when you go to open systems in contrast to lab conditions. So in the paper, we discussed some directions. I mentioned theoretical maturity, constraints of generality, mini theory. We argue that instead of saying my theory is this, if you have theoretical maturity and you list all these constraints of generality, does it make sense to talk about theory or mini theory now? It's very circumscribed. We talk about exploratory research, open science and transparency. Effect sizes from individual studies are usually overestimated. Don't trust it when, a new study says, oh, I have an effect size of 0.5. It might be, even if there is an effect, it might be 0.15 or something. Meta-analytic mindset to disconfirm results. Think not only in terms of replication, but a broader substantiation efforts that cover other types also. So I'm getting to the end of the presentation now. So many solutions, this is an interesting quote. Many solutions suggested for their reproducibility concerns are decades old. Meehl in the 60s, he suggested many things like pre-registration and other things that we do and practice in the modern era. But these are not really new solutions. The reproducibility crisis represents a sober occasion to revisit them. They are not really new, given our accumulating research experience. Invariably, psychology and, apply linguistics also, will still face a reproducibility problem 20 years from now. This paper was in 2018. And maybe 50 or 100 years from now, it doesn't really matter because it's in principle, it's very difficult. Even when recommendations such as pre-registration, open materials, data, and code are standard. So in conclusion, replication is hard. This is the main point in this study, especially with open systems. It's very hard to do this. Even pre-registration, which is now pretty much standard in many fields, even advocates of pre-registration acknowledge that it's very hard, and many people who practice pre-registration regularly say that it's very hard and there is always deviation when they actually do the study after they collect data. It's very hard. It would be naive to think about replication. Oh, just let's do replication, just do the same study again, and then we check the results. That's very naive. It's very difficult. If there is anything we have learned from the history of science, is that anything that is complex, upon closer examination, becomes more complex. So when we look at replication, upon closer examination, the idea of replication is very complex also. And many people will, I expect even 50 years from now, they will, look back at us and say, look at these people in the swinging 20s. They were so excited about replication. They didn't know how difficult it's going to be. So these are my co-authors of this paper, but I have to say that what I said in this presentation does not necessarily reflect the opinions of my co-authors, because I did not give them this presentation to these slides to get their opinions about it. So they may agree or disagree with some of the points that I have said in this presentation references, and thank you for listening to this presentation. Dr. Lee, can you hear me? You are muted.
Oh, okay, sorry. I think my student just accidentally muted me. Okay, so thank you, Ali. Yeah, can you hear me?
Yes.
Okay, thank you, Ali, for your passionate and comprehensive talk about replication studies and the substantiation framework. See, it's the end of the year and it's Friday night, but we still have more than 200 attendees at its most. So, okay, before the Q&A section, let me wrap up the talk. So Ali started with people's attitudes towards replication studies, confusing terminology, different classifications and their related limitations. To address the problems found in replication literature, Ali further detailed the substantiation framework, the proposed, followed by two interesting examples about how to replicate studies on whether to pay reviewers and educational interventions. Both the examples point to the challenges facing replication studies and the need to take a CDST perspective in replication studies. And I like the term open systems. So indeed, an encompassing talk.
With you if you want to share it with them in somehow. So definitely yes.
Okay, great. Thank you. You're so generous. Okay, so now let's move to the Q&A section. So any questions, please feel free to ask questions and leave your questions to the chat box. So Ali, can you see the chat box?
Yes.
Yeah, I think we have some questions already there.
Yeah, there is one question about the reference slides, which I have shown.
Yeah, before that, I see a question from Yuanfei Li, and yeah, because you have already addressed the challenges, so she I suppose she asked whether we should give up replication studies.
Oh yes, this is an interesting question. Should we
Yeah.
give up replication? If you have, the question is increased theoretical maturity. This is a very important consideration. And aim more for mini theories, not grand theories that apply everywhere. If you can develop a theoretical maturity of a mini theory, then yeah, it's possible. But if you are more ambitious and you are studying an open system, an open complex system, then I think it's very hard to do replication.
Oh, sorry to interrupt. Someone asked whether we have to type the questions. Okay, please feel free if you want to. It's okay whether to type or just voice yourself. Yeah. So my students, Gongmiao and Lou please unmute everybody, every attendees. 高淼楼姨把大家的这个静音解开啊。
Hello, Chen Chen.
Yeah, I have a colleague, Du Jianying, Miss Du Jianying. Yeah. Hi.
Hi, can you hear me?
Yeah. Yeah.
Is my voice okay? So thank you for this nice presentation, Dr. Ali. My question is, I'll start with the first slide where you said the goal of science, whether social or natural science, to find regularities, right, in nature. So if we cannot replicate or if we cannot get the same results, so what is science? If you look at the natural science, I don't think they face the same problem. Probably does exist, but it's not to the same degree as social science. So I think, first of all, we have to understand what kind of science we are dealing with, which is social, okay? So my question is, what is the goal of science here? And what counts as a replication in our field, applied linguistics or second language learning or acquisition, okay?
Yes. Did you say you have a second question or that's it? Okay. So thank you for this question. This is a really fundamental question to answer. What is the point of doing research in this case? Now, admittedly, whether in applied linguistics or in other disciplines, there is clearly a bias towards what I call confirmatory research bias. There's always, you have a theory, you have hypotheses, and then we test this hypotheses. There is little encouragement of exploratory and descriptive research. And without this exploratory research, how can we develop theoretical maturity in the first place? And even some textbook writers, some people say that exploratory research methods are, quote, quote, second-class citizens in methodology books. If you open a textbook on research methodology, there is more attention to confirmatory approaches than to exploratory approaches, generally speaking. So to answer your question, we need more exploratory research. You can do replication research, possibly, if you are studying a well-defined phenomena, especially if you are in a lab setting or in a very narrow range. If you are doing something in an open, complex system, this is fact of life, it's not, it's very difficult. What can I do? Maybe we would come up with a solution in the future. Maybe we will just have to live with it, what can we do? So yeah, when you have a complex system, we should encourage more exploratory descriptive research. And until we develop theoretical maturity, from our perspective, it does not make sense to say, I want to replicate if you do not understand what you are studying, because if you get negative results, you cannot question the initial results. So what's the point again now? If you cannot question the study, you are replicating study in order to confirm or disconfirm certain findings. If you cannot disconfirm them, then we are running in circles.
Can I ask my second question?
Sure, yeah, go ahead.
Okay, so my second question, and for example, in physics, they don't do one experiment, so they don't publish results. They do, I think, hundreds of experiments at the same time. They get the same result, then it is published. So you see in, for example, in physics papers, you have like 10 authors or 20 or 100. Why? Because they do. But in social science, you can see what we are doing is like one study, and then after 10 years or 5 years, we do another study, which I think it's not either direct or approximate because we are changing. So it's social phenomena we are studying. So it's not the same thing. Yeah. And by the way, for example, if you take, for example, a Saudi guy learning English 10 years, it's not the same. Probably at the beginning levels, but it's not the same. I would be surprised and disappointed to find the same result. I want to see more progress. So it's not the same group or age or time or teaching or materials. It's different. So in
Yes.
in one way, I don't think it's application, whatever we call it, conceptual, direct, approximate. I don't think 10 years ago it's different from now. I mean, kids right now not the same 10 years ago, so
Yeah.
or 20 years or 30 years. So if we pass this window, it's like physics. If we pass this window where we can replicate, I think it's going to be hard. I think there is, I don't want to quote second language acquisition, but I think there is a critical period for replication as well. Okay? Otherwise, we'll miss the chance, or it will be more highly difficult to do it or to get the same results. Okay? I would be disappointed to get the same result. Okay? It would be for me disencouragement. Okay? So I think there is a window for that. Thank you.
Yeah, yes. Thank you for this comment. Yes, and that's why in different fields, such as psychology, they have a replication crisis. Everybody is practically crying because of this problem. Textbook examples, classic examples in textbooks are being disconfirmed when they try to replicate them now, because replication is not standard. This is one problem. The other problem is that even in psychology, they don't routinely study complex systems. They have graduate students in a lab doing something in a small scale experiment, and even there, they have a replication crisis. Imagine when they go to an open complex system, you can just imagine what will happen. And the question now is that you might be alluding to is that, are we going to have a replication crisis in applied linguistics? I think yes, once we start doing replication research, we will have the replication research in the replication crisis in applied linguistics, provided that we do not just look at correlation research. Because almost by definition, correlation research doesn't really explain to you what you are doing. You just, give it a questionnaire and do a quick correlation or regression, you get an effect size of 0.3 or something. You don't really understand what you are doing, really. It could be interpreted in a million ways. So it's not really it's not a good test of your theory to do observational research. But once you start doing interventions, then problems will arise. And mark my words, we will have a replication crisis in applied linguistics once we start doing serious research that does not rely completely on observational research.
Okay, so maybe we can move to the next question. Considering time limitation, I think we only have time for one or more questions. Yeah.
Hello, Ali. Nice to meet you. I'm Edward, from Macau. Yeah, finally we've got to meet, right? Yes. Can you hear me, right?
Yes.
Yes. Oh, good. Okay, yes. I was expecting you to say something about the complex dynamic system theory, okay? Because Larsen-Freeman, right, in her 2012, paper, repetition, is not repetition, it is reiteration, right? Or iteration. So you cannot step onto the water for the same time, or it's the same thing. Okay, so I'm thinking, I'm just curious, will that be related to replication, repetition, replication, or reiteration? Yeah, I'm just some curious thoughts. Do you have any idea about this?
Yes, in the actual paper, we do talk in more detail about the complexity perspective, more than I did. Let me just show the paper. Right. In the paper itself, if you look at it, we have several pages talking directly about a complexity theory view of this issue. And just like you said, is it in complex system, is it really a repetition or an iteration? Because there is so much sensitivity to initial conditions that you are studying something different now, just like Dr. Roueshid just mentioned now. things change, students change, technologies change,
Exactly.
rules and regulations change, and are you really repeating the same thing, or is it reiteration and different things every time? So
Right.
yes, this is a very important idea. I think that empirically speaking, it is still understudied. We need more research on the concept of reiteration. There has been some theorizing about it, but I would like to see complexity research on iteration itself, like when students write essays over time, or
Right.
when students practice speaking, for example, and other things. That will be very interesting if you are interested in complexity research.
That's true. That's true because modern Christiansen has done similar thing. They have this telephone repetition game, right? We are doing it sometimes as a game in our classroom, right? So this is reiteration. Every time when you are repeating things, actually it's different. It's not repetition. So replication, in my understanding, is no replication. I mean, it could not be the same. So that's the basic understanding. But you have done a very interesting job in using substantiation. So nice talk. Thank you, congratulations, and happy new year. Just to say hi. Thank you, Ali.
Thank you.
Bye bye.
Thank you.
Thank you, Edward.
Thank you, Dr. Lee, for the wonderful talk as well. Yes, for organizing it.
Thank you. Happy New Year.
Happy New Year.
So Ali, maybe we still have time for one more. I think maybe the last question. Yeah. Okay, Ali, we still have some questions in the chat box. Could you check that?
Yes, there is a question about borrowing replication models from other disciplines. I assume the question is about borrowing replication terminology from other disciplines. In principle, there is no problem. If you find something useful in other fields, you borrow that thing. It's a good idea to do actually interdisciplinary research, and not just, kind of superficial. You look at what they are doing and do something. Why don't you talk with them and do joint research with people from other disciplines? Yes, if you engage with other disciplines, there will be cross feeding, let's say, and that will be helpful for both fields, or the different fields that are involved. Yes.
Okay.
Yes, there is a question about the idiodynamic method. Yes, if we look at the idiodynamic method, there is always this fluctuations and going up and then going down, and then even if you take the same participant, not a year from now, not a day from now, just 10 minutes from now, and give them the same task, I'm sure that you will get some different patterns. And that's related to what Edward just mentioned about, is it replication, or is it an iteration or reiteration again? So yeah, for the idiodynamic method, I don't think there has been a lot of attention in relation to the idea of iteration, replication, and complexity theory specifically. So I would like to see some more research on this idea.
Okay, thank you, Ali, for your answers to these questions. And I think we still have, because I have a colleague from my department and research center, she wants to ask a question. So Miss Du Jianying, can you hear me?
Yes, I can hear you very well. Thanks, Chen Chen.
Yeah.
I have typed my question earlier on, but I would love to repeat it. Dr. Ali, thank you very much for this interesting talk. And my question concerns the how can I say, the value of replication. I mean, obviously it's valuable, but they varied in degree. So it's somehow reusing the previous research. In what way? Well, in what way do you see the replication contributes to the theoretical advancement in the field of applied linguistics compared to those replications in hard science? I mean, we all repeat others' research, but in what way our research or our replication differ from those in hard sciences? Do you mind?
In the hard sciences, okay.
Yes.
Okay.
Thank you.
Okay, so one problem with the social sciences, when we compare it with the hard sciences, is that some people argue that it is impossible for the social sciences to become like the hard sciences in terms of precision and exact predictability. And some people said, oh, maybe the social sciences are relatively new. You know, psychology, for example, which is older than applied linguistics, psychology itself is like 100 years old only, while physics and other sciences are, 4 or 5 centuries old. So some people say that the reason why the social sciences is lagging behind is that it is relatively new. But other people disagree with this and say, although in terms of time it is relatively new, but if you look at the amount of research published every year, it's like more than all research in the history of probably physics before the social sciences were born. And just like in a year, we have close to 4 million papers, if you see this amount, and it's increasing year after year. So some people disagree that the social sciences are just young and it's just a matter of time before we become like physics. Instead, they argue that the social sciences are inherently different from the hard sciences in the sense that there is so much, complexity involved, especially when you go to open science. This is one side to your question. The other side is, what's the point? The point is that if you don't have theoretical maturity, as I am pointing here in the slides, if you don't have theoretical maturity, it doesn't really make sense because you don't know what you are doing really, or just exploring and reproducing an effect. If you can develop theoretical maturity, which requires a lot of exploratory research, then it might be possible to say we can start to think about replication. If we are still don't understand what the theory behind what we are studying is, replication becomes pretty much mindless or meaningless. So yes, if you can in your field develop sufficient theoretical maturity and you can explain the necessary and sufficient conditions to explain a phenomena, and you can explicitly detail your theory, then we can talk about replication.
Yeah, thank you very much, Dr. Ali. That's wonderful. Thank you.
Welcome.
Thank you.
Okay, thank you for the questions and answers. I think it's the time to close the talk. If you have any further questions, maybe you can leave some messages to Dr. Ali. Before the end, I would like to say that recently I happen to know that the top journal studies in second language acquisition is calling for replication studies. I suppose you know, Ali. Before the talk, I was quite optimistic and wanted to have a try. But now my attitudes have also changed after the talk. I become much more pessimistic because according to CDST, everything seems to be changing, deviating from the original research. But there are challenges and difficulties. Let's still be positive about replication studies. All in all, thank you, Ali. So also great thanks to all the attendees. Happy New Year. Wish you health, happiness, and productivity in the coming year. I think it's time to say bye-bye this time. Thank you, Ali, and thank you, everyone. Yeah.
Thank you very much for having me.
Yeah, okay.